Welcome to CIVIL-MECH-MATHS Concepts channel. Today, in this lecture, for CAT, GMAT and GRE, Quantitative Aptitude, I want to take up some lecture on intervals and also a brief of number systems. Even though I have explained in my first class about the number systems, please see my previous videos also on this topic. Again, I want to repeat and I want to show how intervals can be shown in a number system and what they mean, like open interval, semi-open interval. On the left hand side it is open, semi-open interval on the right hand side it is open, and closed interval. Even though you know them, it requires definitely a recap or revision on number system and intervals before entering into the real number system problems. Even though I have done on 2-3 lectures some number system questions based on CAT examination syllabus, but still the number system I want to explain further the definitions so that you will not be confused. In the next class I will be taking up the types of numbers like greatest integer number and mod of a number, absolute value of a number, how they can be represented by plotting also through graph visualization so that you will understand better. It's not only theory, I will put the plots and graphs also along with the lecture so that you will understand better the meaning of that particular definition. We'll go further. Here in this lecture, I am talking about intervals in number system syllabus. What are the intervals? We know the solution is, we know already there are different types of numbers in use in this world. One is natural numbers, second integers, third rational numbers, fourth irrational numbers, next real numbers, next it will be complex numbers. The set of complex numbers is the largest. It has the largest set. That means largest number of numbers are available in the complex number. It's a plane. These are all on line we can show. These are all single dimensional line representation. Here it is a two-dimensional plane representation. This also I have explained in my previous classes. Please refer to them. And I will just give difference between a real system and a complex number system just for a minute. When number system is like this, minus infinity to plus infinity, on a single line, having one 0, and natural numbers, whole numbers, integers, rational numbers, irrational numbers, everything will be between this. Here let us say it is root 2, irrational number, 1/2 rational number, and here it is 1, that is an integer or a natural number we can call. Here -1, negative integer, and we can say -1/2. Like this, on the left hand side of the origin, this is the origin with 0. On the right hand side, it's a regular practice to write on the right hand side plus x on the graph sheet. When you take a graph sheet, on the left hand side we will write -x from the origin. But here, a number called square root of -1, that is imaginary number, that is not defined in real number system. Not defined in real number system. What is that? I is not defined. That is square root of -1. I is not defined in the real number system. Then for definition of I, we framed another like a plane. In the graph sheet, we have both x-axis and also y-axis. X-axis is called as the real number system. Real numbers, rather it has real numbers, it's a line. Y-axis line has got imaginary numbers, IMG. We will call it as in short IM, or in long we will call it as imaginary. That means all i's are represented on this y line and all real numbers are represented on this x line. This can be 2i, this can be -2i, like this. Imaginary numbers on the y-axis, real numbers on the x-axis, and except for complex plane, all other numbers can be represented on a single line, real line, whereas complex numbers require a complex plane. It is called as complex plane. Because it is consisting of two sets of numbers, it consists of both real and also real component and imaginary component. For example, if I take a point here P, this value let me say 3, this value let me say 3i, then P will have coordinates 3, 3, where 3 on x-axis is real, 3 on y-axis is imaginary. This imaginary number can be written as, that is, it is a usual notation to represent it as z. Z is equal to x plus iy. Here for the example it is 3 plus 3i. This is only for example. The trace of z is nothing but this is the distance between origin and point P. OP is equal to square root of x square plus y square. This is another important equation you should understand. To find the distance from the origin on a line, we need not find out the xy components because it is only on a single line of x. Whereas in case of a complex number, the magnitude of OP, this is called as magnitude. Magnitude is equal to square root of x axis component plus square plus y axis component square. In this case, it is square root of 3 square plus 3 square. For the example we have taken. Now with this introduction, we will move forward. Now, We are talking about the intervals. I will be taking up the intervals on the real line in today's class. Real line. The complex plane intervals are little bit complicated. I will be taking up in the next class. Those intervals also we will do. Intervals, understanding intervals is very, very important. Real line intervals we are talking about. What is real line? For that one I have given the introduction to you. What is a real line? This is the real line. This is up to plus infinity. This is up to minus infinity. In the first, what we have to discuss? X, open interval. What is open interval? Open interval means open on both ends. For example, you go to market with some 100 rupees in your pocket and you want to purchase some item. You keep in mind that I want to purchase that item between 70 and 80 rupees. That means the cost of the item can be more than 70 rupees and it should be less than 80 rupees. That's an open interval. I am not including 70 and 80. When you do not include the end points, then that interval is called as open interval. For example, 70 is less than x is less than 80. That means I am playing between 70 and 80. I am not including. Here, this bracket, it denotes, this type of bracket denotes exclusion. That means 70 is excluded from your option. Here, exclusion, 80 is excluded. Here you see it is equal to greater than and this symbol is less than. When I say 70 less than x is less than 80 means I exclude 70 and 80 endpoints in the range. If I say 70 is less than or equal to x less than 80, then 70 is included, but 80 is excluded in the interval, in the range. This can be written as 70 is less than x is less than 80 can be written as in shorter form 70, 80. That means intervals are open. Open interval and end points are not included. That means here end points not included in open interval. If there is a equation, this is one. If there is some decision in your mind that you purchase an item for 70 but you will not go beyond 80, but you will exclude 80 also. You will not go equal to 80 and more than 80. Then it will be written like this. 80 is excluded. When something is included, it will be represented by this notation box. This is included. This notation. Then how do you write this? 70 is included. That means we will write like this. 70 and 80 is excluded. That means one end is included, other end is open. That means semi-open interval. These are very important, may look simple but very important when you are doing your real mathematics in CAT examination. These basics are very, very important. Now, did you understand this? This is semi-open interval, and semi-open, where it is open? Right hand side open. Open on right hand side. For example, third case. I want to exclude 70 but include 80. This is also semi-open because one side it is open and another side it is closed. This can be represented by 70 and 80. It is semi-open. Open on left hand side. LHS is left hand side, RHS is right hand side. Next comes, I want to include both 70 and 80. I want to include both 70 and 80. 70 is less than or equal to x. X is less than or equal to 80. That can be represented as both closed. It is closed interval. That means 70, 80 is closed interval which includes both endpoints. In the above intervals, we have spoken about finite intervals. Finite intervals means the interval is between 2 points, known points. For example, there are another type of intervals called infinite intervals. What is an infinite interval? Let us say there is a open interval on the left hand side A, and on the right hand side it is an open interval with infinity. That means the real line is going from A here, let us say it is origin O, this is at point A, and it goes. The right hand side point is not defined. It goes up to infinity. It is an open interval. Here in A also it is an open interval. A is not included. A is excluded. For example, this is 1 and second can be. A is included, but right hand side it is infinite. Third case, left hand side it is minus infinity, because if you go this way it will be minus infinity. The interval is not defined, minus infinity, but a is defined on the right hand side. Fourth, minus infinity on the left hand side, both sides open. Now, I have already shown one representation in the real line. Try to show them as represented in real line. Try to show them. It's your homework. Because mathematics can be understood, or in the examination you will be able to do mathematics when you practice mathematics. It cannot be learnt by viewing or listening. It should be done by you. Hence, in all my lectures, I will give good number of homeworks and kindly represent these three in the real line, on the real line. Please do it. It's for your benefit. Now, with this, in this lecture, what we have learnt? Finite intervals, two infinite intervals, and both of them have one open, semi-open. Semi-open is of two types, right hand side open and left hand side open. Or we can even call it as semi-closed. Right hand side closed or left hand side closed. And closed. That means in each finite intervals, three cases are there. Infinite intervals, three cases are there. All the 6 cases of intervals are discussed in this lecture. In the next lecture, what we will be going to do? It is on the real line. These are all real line intervals. What happens if it happens in the complex plane? How do you show them? What is its mean? Complex plane intervals we will be discussing in the next class. And once you are thorough with the intervals, then we will go for greatest integer, absolute number, equations involving greatest integer, equations involving absolute numbers, how to solve them. Thank you. With this, I want to stop this lecture. Best of luck to everybody. Thank you for listening to me. And if you feel there is a value addition to you because of this lecture, kindly share my video and subscribe to my channel CIVIL-MECH-MATHS Concepts. Best of luck to everybody. Thank you.